Welcome back to RamZland. Today I'm going to show you how to make your own Lego diver. When I tell my Lego diver to dive, he dives. And when I tell him to rise topside, he goes back to the top. Is it magic or is it science? Check out my hand when I tell him to dive. What am I doing with my hand? Looks like I'm squeezing the bottle. And when I tell him to rise, I let go of the bottle. Is this magic or is it science? Two words I want to teach you in this lab is buoyancy and density. When my Lego diver is at the top, we say that he's positively buoyant. Buoyancy is just an object's ability to float. But when I tell him to dive and he goes down to the bottom, that's when he becomes negatively buoyant because he's at the bottom of the volume of water. And if he's right in the middle of my volume of water, we say that he's neutral buoyant because he's not ascending nor descending. The second word I want to teach you in this lab is density. And this word is going to give away the essential question, why does the diver dive? And density has to do with the amount of mass that can fill up a given space. If you notice, when my diver dives, I'm squeezing the bottle and the water inside the bottle has nowhere to go except inside the dropper that's underneath my Lego figure. If more water goes into the dropper, it becomes more dense, causing my Lego figure to dive. If I let go of the bottle, that little air bubble underneath my Lego figure, it expands, forcing a little bit of water out, decreasing its density, allowing my diver to rise. Again, as I squeeze the bottle, the dropper takes on water, becomes more dense, causing my diver to dive. If I release the bottle, that little air bubble expands, forcing the water out, decreasing the diver's density, allowing it to rise. And now you're ready to try it yourself. All you need to build a diver is a water dropper, a hex nut, and a 2-liter bottle. First, fill your bottle all the way to the top. Cut off the end of your dropper so it's about this long, and then twist a hex nut onto the end of your dropper. Once the hex nut is twisted onto the dropper, make sure it'll stay on. Prime the dropper by filling it 1/3 with water so that it counterbalances the little air pocket that's inside. And then you're ready to put your diver in the bottle. And it's buoyant, it's positively buoyant. You want to top off your bottle with water so it's filled all the way to the brim. That way when you squeeze the bottle, the water has nowhere to go but back into the dropper. Once it's filled to the brim, screw on that cap really tight so when you squeeze the bottle, it doesn't leak. And now you're ready to test your diver. When you squeeze the bottle, water goes into the dropper, making it more dense and causing it to dive. When you release it, your diver goes topside. I hope you enjoyed this presentation on density and buoyancy. Remember, density is the amount of mass that fits in a given space. Buoyancy is an object's ability to float. And the Cartesian diver that we have here illustrates both.